Okay, I'm not going to go into a great bit of detail on these two, just a couple of pictures. But on board number 2, I'll show you the complete solution for computing the derivative of this function and simplify. Okay, so here we are on board 2, the derivative of the inverse tangent function, of course. If we just have an x in here, it's 1 over 1 plus x squared. And for the derivative of this term, we have to use chain rule, which requires the use of the quotient rule. So here I have 1 over 1 plus this thing squared times the derivative of the inside, which is this thing. And there I have to use the quotient rule. So denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Now in the next step, I've actually visualized taking this denominator times this denominator. And so I'll have 1 minus x quantity squared times this 1. And then when I take it times the second term in the denominator, the 1 minus x, the quantity squareds, will drop out. And I'll get 1 plus x, the quantity squared. And in the numerator, if we say negative 1 times this negative gives me a positive 1. And remove the parentheses, I got 1 minus x plus 1 plus x gives me just a plain old 2. And now let's see, let's square these binomials, combine similar terms, see what happens. Well, this is what I get in the denominator. These 2's factor out, and I could say I'm going to divide every term, numerator and denominator, by 2, and I get 1 over 1 plus x squared minus 1 over 1 plus x squared equals 0. So that means this original function must have been a constant function. And here's kind of an indication that that's true. By the way, here's sort of how to take the limit as x approaches infinity. Rewrite this by dividing numerator and denominator every term by x. And then as x approaches infinity, I probably should have the limit here to as x approaches infinity. These terms approach 0, so I'm actually taking at the limit the inverse tangent of negative 1, which is negative pi over 4. As x approaches infinity, the angle that has a tangent of infinity is pi over 2. There's the limit. Okay, and here's the constant term, f. Here, the green, well, you can't see the green because what I did down here with h is add on this 3 pi over 4 vertical shift, and it turns out this graph shifted upward lies right on top of inverse tangent of x. That's why when you subtract, you get 0. Okay, that's what this black line is. It's the same as f of x. Okay, there you go. Hope that gave you some idea. And if you have any questions, post a comment.